Hello, everybody. Welcome to week 5 of Math 1220 online. So just a few announcements. The exam is not this week, but it's next week, so February 13th to 17th. This week you're on web work and written assignment number 4 on section 7.4 to 7.6. But I want to say some stuff about this exam next week, February 13th to 17th. Main thing I want to say is make sure you schedule it if you have not already. You schedule a spot in the proctoring center through the schedule exam links on Canvas. If you wait until the end of exam week, they will run out of room and you won't be able to take the exam. So do schedule in advance. If you don't schedule this week, be sure to schedule over the weekend before the exam week. Otherwise, you may not be able to find a time to take it. Good. If you are an out-of-town student and you cannot schedule using the schedule exams tool, then you will need to find your own proctor independently and verify the details with me as soon as possible. There's a little bit more about this in the syllabus, and please contact me if you have any questions about that process. And then the last thing I want to announce is I just want to point out the office hours are a little bit different during exam weeks. So I'll have my usual office hours on Thursday, February 7th from 1 to 10 p.m. to 2:50 p.m. This is sort of my normal assignment week office hours. And then the office hours for the next week, so for the exam week, will take place actually on the Saturday before the exam week starts. So that'll take place on Saturday, February 11th. And there will be none on Thursday, February 14th. So if you look at the office hours page, this is the normal schedule for office hours. They're always at 1:10 p.m. to 2:50 p.m. on Thursdays during assignment weeks. And then in exam weeks, they're always moved instead to the start of the exam week on the Saturday before. Good, so just pay attention to that if you're hoping to go to office hours at some point before the exam. Those are your two opportunities. Great. So a little bit more about the exam and what is on it. It's 90 minutes. And the proctoring center is very little bit in how they handle it. The proctoring center, I just want to point out, they may not be keeping track of time for you. So exams out any longer than the time limit will have points deducted. So do just sort of see how things are working at the proctoring center and make sure you're keeping track of the time. But yeah, so if you don't sort of have it turned in 90 minutes, you'll start losing points afterwards. And this is explained a little bit more in the syllabus if you look on the other important info on page 4, if you're curious about that. So the exam covers the material we've done in chapters 6 and 7. That's web work assignments 1 to 4 and the written assignments 1 to 4. You're not allowed any notes or a textbook or any other materials like that, but you are allowed a basic non-programmable graphing, non-programmable non-graphing calculator. That's okay. Let me emphasize here that it's okay to have one of those. You shouldn't need the calculator, actually, and this exam is sort of written so that you don't need a calculator, but in case you want one, you can have one. But it should not be programmable or have graphing functions, or you won't be allowed to use it. So the exam is taken sort of in the proctoring center on the computer. So in Canvas, let me write that here. So exams really is in Canvas. But you sort of take it in the proctoring center. So even though it's in Canvas, you sort of take it through the proctoring center. So while you're in the center. Half of the exam is sort of multiple choice or fill in the blank, and half is written answer. So the multiple choice and fill in the blank questions, you'll submit your answers directly on the computer, and the written questions, you'll submit your answers on a provided answer sheet. So when you take the exam, you'll get an answer sheet. The written questions will also be on the exam on Canvas, but you'll write your answers for those ones on those provided answer sheets. Okay. And so if you want to get some practice, especially with this format for taking an exam, there's now a practice test available on Canvas. You can find that in the quizzes section, or if you click this exam 1 information and resources page, there's a link to it there with also a little bit of information, a link to solutions and so on. There are also older PDF practice exams available. I moved that link inside of here and also provided another link to one of them that includes solutions to try. Good, so you have lots of resources to use. I recommend in particular using this practice test on Canvas really as a genuine practice test. So like give yourself 90 minutes, work on it, don't use a calculator, don't use your book, like don't look things up, like really use it as a diagnostic practice test after you've already done some studying So that way you can sort of figure out where you're at, what your strong points are, what your weak points are, rather than sort of like using it as just like some questions that you're going through. So I'm really using this practice test like really as practice. Okay, great. So that's, I think, everything I wanted to say about the exam. And again, if you want any more information and more resources, click this link on Canvas. It's at the top of the front page for this course. The formula sheet is also there. So there used to be a link here for the formula sheet, and for old exams. Now both of those links are in after you click on this page. So just a little bit about this week's math. Well, we're doing more integration. I know you're probably feeling a little bit tired of it now after that long web work assignment with those sort of complicated, a little bit exhausting integrals using like trigonometric substitution and integration by parts. I know those sort of take their toll. I don't much like doing them either, to be honest. Good. And so we're doing a little bit more on integration techniques. I think these ones are a little bit more straightforward, and it's still some work though. After this week, we'll be done chapter 7. Chapter 7 is like this whole integration chapter. It's really just like, it's about all these methods, and it's just about sort of applying these methods to hard problems, and like it's a lot of work and maybe not as interesting as the rest of the stuff in the class. So if you're feeling sort of a struggle right now, I'm sympathetic to that. This is but I think sort of the class is sort of up, like is a lot more fun after this week, actually. I feel like the stuff we do after the first exam, I think is a lot more interesting, a lot sort of more conceptually exciting, and less about just like, here's a hard problem, solve this hard problem. So I'm looking forward to that, again, to that, and I hope you'll look forward to that too. So what are we specifically doing in terms of integration techniques this week? Well, we're doing rationalizing substitution. So that's about how you can make a substitution to get rid of a radical in the integrand. So if the thing you're trying to integrate like has a square root, for example, sort of how can you make a good choice of substitution to get rid of that square root? And so there's some like options like using, there's some really basic examples, and then there's sort of some more complicated examples where you use sort of some trigonometric identities to do that. But you'll get to see that in 7.4. Then 7.5 is sort of, well, about, okay, like 7.4 is sort of about getting rational functions. So the quotient of two polynomials in an integrand, that's sort of what it means by rationalizing. So as you sort of get rid of radicals, then sort of ideally you're left only like with a quotient of like a polynomial p of x over q of x. And then the question is, how do you integrate that? Well, in simple cases, sort of we already know how to do this, but if like the denominator is pretty complicated, this can be a little bit tricky. And so there's a method for this called partial fraction decomposition. And basically that's a method that lets you rewrite p of x over q of x in a way that lets you sort of easily integrate it. So actually in secret, you've already seen sort of simple examples of this in past problems, but this sort of gives a more systematic way in order to write sort of these fractions of polynomials, these rational functions, in a way where you can integrate them. So that's what 7.5 is about. And then 7.6 is about strategies for integration. So that's not sort of really introducing any new ideas, just sort of bringing together all of the ideas from these previous sections into a coherent system for solving, for computing integrals. So that's what we're doing this week. Good luck, and I'll see you hopefully in office hours or next time.